What's going on, guys? My name is Josh, and today we're going to be finding the minimal polynomial of Q join square root 2. That's the field extension over the irrational numbers, and we're going to be using Galois theory to find it. Specifically, we're going to be using this formula. So basically, we have that the minimal polynomial over Q equals the product over sigma in the Galois group of L over K of x minus sigma of alpha. So yeah, basically we first need to find the Galois group of this field extension. So to do this, we're gonna let sigma map square root 2 to negative square root 2. And that means that if we apply sigma of square root 2, or if we apply sigma to square root 2, then we get negative square root 2. And sigma squared is not a unique automorphism. It goes back to the identity, because if we applied sigma squared to square root 2, we can compute it like so. So basically, we can do sigma of, so we already stated that sigma square root of 2 is negative square root of 2. So we have sigma of negative square root of 2. And we can take out this negative since we're still using properties of field extension or fields. So we have negative 1 times sigma of square root 2. And that means that we have negative 1 times negative square root of 2. And we just get back square root of 2, which is our identity element. So basically, we can use this formula now that we have our Galois group, and our Galois group is now it's just denoted GAL of Q join square root of 2. And technically, yeah, that's over Q. And we have that. That's equal to E and sigma. Okay, so now that we have our Galois group, we can actually apply this formula. So we have that. Looking back at our formula, we have x minus sigma of alpha, where I should have stated that alpha equals square root of 2. So now we can apply our first automorphism. So that's just E. We'll denote it E of square root of 2. And we're going to multiply it by x minus our automorphism, our unique automorphism of square root of 2. So now we have that, we have x minus E of square root 2 is just square root of 2 times x minus sigma of square root 2 is just x minus negative square root of 2, and that's just x minus square root of 2 times x plus square root of 2. So we can use the difference of squares formula. So we have x squared minus y squared equals x plus y times x minus y. And basically, if we apply this this logic to this, we have that that's going to be x squared. So we have x squared minus y squared. In this case, our y is square root of 2. So we have that. We have x squared minus square root of 2 squared, which is just 2. And that is our minimal polynomial. And yeah, so that's about it. It's a little more tedious compared to finding, like, normally we could have just done like alpha equals square root of 2 then alpha squared minus 2 equals 0. We could have just done that, but this could be useful for certain things that maybe it could be a bit difficult to apply the same algebraic logic you would for finding a minimal polynomial to certain elements, such as maybe roots of unity, which we're going to talk about later in the series. But yeah, so for regular algebraic elements like this, I don't think it's really useful, but it helps us understand automorphisms, which I guess is a cool thing. But yeah, so that's going to be it for today. I hope you guys enjoyed this video, and I'll see you guys in the next one. Peace.